Good evening. No, not that. So I still think I need to do a better abstraction into the library for drawing these arcs, but for the time being, and actually, the other thing I'm noticing is drawing order. Well, eventually they shouldn't intersect as much, but if there's any definable difference in color, I may actually have to layer these separately. But the issue I run into is the way we're drawing these arcs right now. I had to extend the drawing library. It seemed like a generic way to do that was to do a visor curve. I've been thinking that maybe some sort of arc might actually be a better interface for that library. But I don't really know what parameters I want in terms of the library. Because with the application I'm doing, it's convenient to specify the exact endpoints. But I know like the canvas interface was like a circle and angles, which you can calculate from the points. But I don't actually know what the right interface for the library would be. Now, switching up my interface could make things a little bit easier. It's certainly possible to solve these kind of break a little bit if we start pushing them larger, which is it's the blue arcs that need to be a lot larger. The red could be a little bit larger, but it's barely enough right now. And the colors are just arbitrary, so I can tell them apart for the moment. But in order to make those larger, I think the quick and dirty way to do that is to bisect it into two arcs, which I kind of have to calculate that point anyway in order to put the boon there. So that's kind of makes that an acceptable thing to do, even though maybe we end up duplicating it. This is kind of for two different purposes. Where the heck are we doing this? Okay, we had a little arc helper for the two different types of things. Which used all this, which gave us our cubic curve. So that is all of those points. We could write this so that the arc says, oh, well, that's too big an angle. We're going to split that up. But we do need that point elsewhere. Now, the point's going to be a little bit different for these. It's not going to be necessarily at the midpoint. So we have the centers of all the gods. We can look that up. Why were we doing midpoint? Oh, we were using the midpoint to place the center of the ring, which was which, depending on given a point and a point, that affects the radius of the circle that you end up drawing. Well, I guess that does. This form is just generally limited to not drawing like things that are much bigger, which I guess being limited to 90 degrees, okay. Well, no, I guess if the center was way out, you'd have the long arcs to there, and that would kind of imply the really big thing. Now, for our purpose, we only need to bisect it by 2. We don't need to account for, I guess, up to 4 sections. So what are we going to have to do? We're going to have to say the radius to these points, which we could either just know or could just figure out. Oh no, we have to figure out where where our desired center is. Then figure out the radius to these points. And then project that on this line, I guess. Or whatever the midpoint line is. Such that it intersects with the farther point of that arc, interestingly enough. Maybe we could treat that as that's an angle operation? I'll say, so given a simple case. We're going to have a point and a point. And we were using this. And what was I doing with that? Yeah, so that was the center. From midpoint to there. So we were kind of like getting something down here, and as it went up this way, it became a problem. I need to be able to calculate this point for a center, up here somewhere, which I think would just be a negative interpolation on this, effectively. Which means we do that. What? We get... the distance is the radius to there. Now, this is like a percentage right now. This is not a distance. And then we know, actually, that would just be a straight vector addition. Well, we can get the unit component here. A new straight vector addition to say, well, that really ought to be that point. Where the intersection is, and then hope that works out. All right, so we need... Now... I guess that could all be one... Well, we called it arc and did point to point. So I need to change my primitive, because that could all be one Beiser curve passed down. And in fact, there are forms of Beiser curve that would be a little bit more efficient there even. But I don't know if I really want to... I'm still not sure what that library interface should be if I want to be exposing all the different forms of that. Now, center is actually going to be confusing here. These are really going to be like endpoints. All right, so do we care about our midpoint now? Well, I guess that would still be used. That would still be the. Well, effectively, this is kind of giving us that vector. Do we just want to get the vector and say it's a distance out? All right, so now this then ends up being the center of the circle. And we are not quite sure where we want to put this. This is actually not going to be how this works, and it does not, in fact, does not work right now because of the wide angle problem. So that moves a little bit out that way. And then I don't have a distance, do I? Not yet. So the resulting radius. Actually, do I need to calculate the radius, or I just say what the radius of the circle I want is? And then calculate the point from there. I mean, it's going to be some kind of constant numbers, but... And nor do I know what the proper number is. So I don't know if I might still have to position where the center is. Or do I just say how far out I want that along the line of... Oh, it is still kind of along the line, the vector to that? Or do I... No, right. Center is still a parameter to the arc. We do have to do that. It's like, could I just kind of do this to find my endpoint? We still need the center. Well, this one I'm wondering if I should get the vector to the endpoint and then just kind of declare distances from there rather than kind of doing this proportional thing. So midpoint to 0, 0. Actually, it's not quite a unit vector, but midpoint to 0, 0 is, since we're 0, 0 centered, is actually just kind of a vector. It's just going to be some arbitrary distance. So we would want to what? No, we're on a unit circle, so it's always semi-normalized. Not fully normalized, but I guess since we're going to end up dealing with two different types of things, that is going to be a little bit of a, like this one's going to be here, that one's going to be kind of like here. And we're ultimately going to want to care about how far out here we are. So there's the midpoint. We would normalize that to get a vector, and then we can say how far out we want the center on the overall setup. And from that center, you know what I actually want to place is kind of where that is. But then I have to solve some kind of other equation to figure out where the center of, I mean, I'm sure that there's an equation for a circle of 3 points. And for circle center for 3 points. This might be a product. Ooh, this is some pretty intense math. XY, GXY. Oh, and F. I'm not sure if this is an easy thing to calculate. I mean, I guess the matrix form is maybe how the computer would do it. Calculator. Oh. Now you see, this might be an easier thing to understand. Now, this is knowing which points are adjacent, so to speak. It's the intersection of, well, yeah, perpendicular to two midpoints. I don't know if that works with any. There's the intersection again, but it's kind of knowing the, well, we sort of do in this case. Because we have a very, very regular system. That would be find the midpoint of this line and the midpoint of this line. And really, we could do any one of those and just intersect it with this. Which I guess technically this is another one of those lines that just happens to have that point. Then again, I guess this radius calculation isn't that hard. And we want to do it in terms of this because where we want to place that icon is kind of how we're actually thinking about this. So I normalize you put this at a certain distance out. And then I can actually well, that would be another midpoint. And then midpoint to there to intersection would be one way to do it. Or, right, would we have the radius at that point? We wouldn't have the radius at that point. So if we get the midpoint, that is a zero-based circle or zero-based diagram that is going to be a vector, not a unit vector. Actually, yeah, this is a single vector, not two. So the fully functional way to do this is we get the length first. What is that? That is square root of... Does Elm have POW operators? Exponentiation. If I recall, oh, we have to do that. Oops. And then we have to scale it back out. Oh, we've already got a scale. So we're bringing in that library. Okay, so no syntactic issues so far. So given our midpoint, we want our unit vector. And I'm not really sure what we would call it. It's like kind of the center vector radius. And our icon point is going to be, I don't even know where we're at. Then to figure out the center of the circle defined by those points. I might have to do the, well, let's see. So what is a line intersection? It is, we take the midpoint of icon point to any of my either sides, which we already have at midpoint point to point. And the intersection of that with this vector is the center of our circle, which means we have to be able to do a line intersection. Ugh. Matrix stuff. Well, I guess it might come down to this. This is more complex than I was hoping, but it probably, given two line, oh, is that line equations? Given 2 points on each segment. Well, one of them we know is effectively 0, because it's that and that point. It would only have 1 point. Well, so first we have to find perpendicular. Yeah, so it's weird that we like do this extension. But if it's just 1, then How does that even work in? A1 is A1 B1? Because these are like the constants. ABC, ABC. This is like the point is XY1? We don't really have a formula, do we? Do I want intersection of vectors technically? Maybe a vector could be easily turned into a... Oh, no, wait a minute. A vector is not the same thing as a line. If we have a point that's on there, we actually have to use one of the other points to define a line, and then define the perpendicular. So what is that? Perpendicular... line formula? Parallel and perpendicular. Okay, this assumes you have the equation, which... Do we? Oh, slope. Well, a slope is just the vector. So if we can solve the vector, we just have to invert it. What is a... No, that's the slope. The slope is -4. 1/4. Okay, they're showing this line here, but it's not actually at 7.2. So we have an icon point. If we did the midpoint between that and either point, it would have the point on that line. That thing would have a slope. I guess we take... Actually, I guess if we did a unit vector, would that just be a swap xy? There's probably a very particular way to... If we don't care about the direction, it would work. So there's the icon point. There is... I don't know what we call this. It's another midpoint. Mid A equals midpoint, end A, and icon point. So let's say vector. I guess the vector from that to either of its points. This is not 0, 0 like the other one was. So this would be, do we have a sub of... If we did a sub of something, it was not in here. Oh, you know what? I did do some vector math. Because we had to do some of that for... and their scale. Well, maybe we're doing enough of this to have... There probably is a vector math library. I don't know if it has the stuff I need. I think this was focused on 3D. At point... we've kind of got points defined by our library, which might make some of these awkward. Add, sub, negate, scale, normalize. Normalize direction length, distance. And it'd be fairly easy to convert. All the vectors. This is more of a generalized... Yeah, this is kind of a fixed length array rather than geometry. What's your... Cannot be used with WebGL, but is used for anything where fast linear algebra is needed. Okay, so you might expose your underlying type. That might be the main difference. That would change the length. So it's not convenient for our points. Although, actually, I'm not seeing... I mean, if we need to do projection, that's there. There's not really anything we haven't defined yet. Well, dot product, which is not a hard thing to do. So yeah, there's not... I don't know if there's enough there to... I mean, I might want to pull this out so I can use it here and there. If I start defining geometry, then actually we might want to be thinking about, well, a line actually is a point and a direction or something. I mean, this is just vectors right now. Well, points, which we're sometimes using as vectors. I guess, yeah, I mean, technically, like if you sub, is it still really a point? That's more like a point is a vector, and you would add a vector to a point, maybe? If you were being properly official about it? I guess, and we're kind of redefining point everywhere. Are you gonna expose everything? Maybe at this point. We might just read at least point. Actually, I'm not sure if collage exposed that at all. I want to make that like G or something. Or should I do like geometry dot vector? Because I mean, like, what if it ends up we end up having like a line sub or a 3D sub? Okay, so the stuff we had, fooling around with here. Ah, yes. We kind of ran across that. All right, we just add somewhere else. Oh, drag to. All right. Boon chart. Actually, collage probably exposes point. So it does have that. Ah, yes, all the Hades files. It'll make some of this stuff a lot more awkward. I guess I could go an alias at all. Okay, so we needed a what out of that? Was it add and subtract? To get an actual, well, I guess some of the lines are just as 2 points, and we did in fact have 2 points. Hey, Athena. That one was in 2 points. That could be 2 points if one of them was 0. Then I don't even need the sub. That's from the formula of a line. Oh no, it was line plane intersection. I found it difficult to think about where a given choice might lead you in the future. The reference is there, but you kind of have to pick one god and then scroll through this big long list, and it's not good. And it's nice that it's there, but it's not good. I mean, this is almost an art project, but it's kind of like an information art project. I don't know. I also remains to be seen if it'll work, and it might need, in addition to the big global chart, I might have to do a full dynamic layout that's like just the things you have. That will definitely need some, either have to be something like watch the save file, although that wouldn't help for boon choices as much, or that actually has to be a full-on mod somehow, so you can get that when you're making choices. Oh, right. The 4-point version is very involved. Now, what the heck is... Oh, because it's the intersection, px, py. And if one of these is 0, then some of those terms will disappear. So maybe that's not as bad. Yeah, and it's a hard thing to describe. It's like I kind of want something equivalent to, so like you've seen some of the like JRPG things that have like the big skill trees. You can kind of move from point to point and point, and that like unlocks other things. And Hades isn't quite that. If it was designed for that, there wouldn't be nearly as many crossings and weird combinations. But you can kind of make it work. And the big problem is with the duos and stuff that, like, if you're kind of looking at like one individual area, you're not really able to see what that is. I might like actually want to put the information like on the edge that's departing, saying, oh, well, if you go this way, you get there. Oh, I guess, is this a, given 2 points on each line, given 2 points on each line segment. Oh, this is if you want to know if they intersect between those points. Yeah, we only care about the infinite case here. Weirdly enough, this almost feels simpler. Line equations isn't bad, but I'm not sure I have that here. I guess that's point and vector to get the slope, and that one of the points is your offset, but I'd have to think through it. Yeah, I'm way out of practice too, so I'm just kind of having to look things up as I go. Okay, so these are like the x and the y terms. Sad thing is we could kind of simplify this knowing it's that one of them is 0, but then you wouldn't have a general line intersection formula to be potentially reused. Ah, yeah, calculus was a bit of a struggle for me. I went back to some of it at some point and kind of got a sense for what was going on. They definitely didn't understand the whys going through school, I think. What was that about? Uh, what did I call that? Oh, I forgot those colors are. We dropped something there. No, those must not be network frames. Yeah, I updated my graphics driver, and I've definitely seen some of the background work impacting video display. And I guess OBS is using video codec stuff, so maybe that's the same thing. Is that... Well, I did a Hades since then. That was fairly interactive. But yeah, I might have to start rolling back driver versions until that quits out. Yeah, I definitely never super got into it, and I still don't know if I have a good sense of when to use it. Right. This is parallel and perpendicular, but this assumes that we have the formula. Yeah, y equals mx plus b. And which we could get there. Oh, are we saying it was just normalize the difference and flip the terms? We take a vector, flip it, and then add it back to the original. So that was other stuff. We got the midpoint. All right, to get that, we needed a sub. Yeah. Non-enemy's hitting hard. I don't know if the direction matters. Actually, if we end up normalizing, we don't need the, well, we need the midpoint later. If we know it's normalized, flipping it's not a big deal. I don't know if there's a good general like geometric operation to describe that. Hmm. Would a normalized vector be, well, I guess not exactly a slope because it's a two-dimensional thing. A slope is a single factor. There's probably a way to translate that. Rather than the direction of the line, we need to have, I don't know. That gives us 2 points along there. The 2 points along the other line, the center line, would be 0 and our icon point. I wonder if there's a straight up trigonometry solution for that. Although I guess with, once these things start getting out, would it still be above somewhere? Well, actually, the center of this, we're trying to push it up more, so it's still kind of above there. Well, I mean, this is actually working on a midpoint of a line to a vector. So yeah, I guess that's would be basically the same in a trigonometry sense. But we have to have that line intersection. Now, at one, no, I don't know what the radius would be. All right, anything syntactically wrong? Doesn't seem to be. Intersection. I haven't really defined a line here. ODEs? I don't even know that acronym. All right, so you're using x1, y1, x2, y2, x3, y3, x4, y4. So we've got a denominator that is a common thing. Okay, this is implicit multiplication, which also has implicit precedence. Y1 minus y2 okay. Actually, now I'm wondering if one of these is the dot product. So these are for arbitrary vectors. Geometric definition. No, none of these are looking like the same thing. Well, this is this saying that vector is that. Man, that's a times ab minus ab, so that's not quite the same thing. Yes, I think I was using dot products in 3D geometry for like to get angles between things and such. So there's our denominator. Ordinary differential equations. Okay. So what's not ordinary? Is it like going to have imaginary numbers and stuff? Wait. Right, point x, point y. The problematic differential equations? Partial. Uh. This is going to be entirely too many parentheses. Well, I might be able to cheat on some of the inner products. Are some of these... Some of these are shared, although I don't know what would make it any clearer. So this is like the direction of line 2. We got x3, x4, x1, x2. Yes, those do all recur. Y equals x. The z equals... Oh, okay. x1 minus x2. And it is y1 minus y2. So then these all become dx12. Maybe if I turn these into proper lines, would dy12, there'd be a better name for that? dx34. Yeah, I've forgotten too much of it to flash by. Yes, those are multiplications. That is times dx34. That's the repeated term. Minus dx12 times x3 times y4 minus y3 times x4. Okay, I can see a pattern there. And there was nothing there. And then this is probably... Oh. Those terms technically repeat as well. I'm not really sure what to call them. Well, it's all 1-2 stuff. And the other one's all 3-4 stuff. So this has to be, getting something into like the derived properties of the lines. And our final answer is nx divided by denom and ny divided by denom. There's probably a reasoning behind that. An alternate approach might be to rotate the line segments so one of them is horizontal. Resolution of the rotated parametric form of the second line is easily obtained. Careful discussion of the special cases is required. All right, are we syntactically correct? No. Oh, that was n. dx dy, dx dy. Guess yeah, we use all that stuff. All right, is this making any sense? Okay. Yeah, so that gives us 2 points. So our potential center of the circle is from mid A2 to zero, zero to icon point. I guess I kind of need to know what my inputs are. Oh, and then I actually have to use this for other stuff, so I don't want to call this yet. I want to call this center yet. Because this is not set up to use what we've determined here. That's just AB there. I guess end A and end B really. What this is going between. Oop, not compiled yet. Intersection. All right, you were you're parenthesized. Okay, given points that are different in sign a little bit. Okay, this is a near zero, which probably means that it's like these 2 points, for instance. Possibly. I guess we also have symmetry here, here, and here. So that's basically 0. And like a 0.5 doesn't seem unreasonable. All right, now, let's see, we have icon point is going to be the thing for our arcs. I did not do a thing to like add paths together. I don't think geometry has that either. I don't remember defining. Yeah, I didn't define an operation that would do that. I don't think they. A way to combine paths. You have lines, you have segments. That just gives you a path. All you can do is trace it, or you can close it. Maybe the idea was to possibly expand that later. In any case, we just need to do this twice, which means yeah, right now we have to trace each of them. Now, this is just doing the same thing twice. Okay, so the center is in fact going to be, actually I'd never end up using this. We have from end A to icon point, and from icon point to end B. Well, we might be something wrong there. Oh, we're kind of going to update. So I guess I need to start drawing some of these points, really. Now, the debug logs are actually probably hurting us a little bit performance-wise here. Yeah, not as chunky. So I see that as an arc. It's not a circular arc. I don't even, well, yeah, if the directions are wrong. Maybe we got that little thing. I'm not even sure what's going on here. Now, so yeah, this one's cockeyed. This is like kind of, it's going point to point, but the center is like, I mean, these were the arcs were looking pretty good before. These just went crazy. I guess if the center is like really out of, not where it should be. Oh, well, we're gonna got a stack here. We would want to do like tiny circles, or even I guess squares would be easier. And I might have to look at stacking order here. So we want a square. Let's just start getting this stuff down. Oh, this is going to have to be transformed. A square of, and is it shift? We do want to know that one. Okay, the shape that is a collage. Sorry, we have to do, it's not traced. I guess we would want this to be filled. And maybe we have to apply this to a filled thing. That is pretty wild, all right. I would say I've got some maths wrong somewhere. Okay, so you can't even see these. Oop. Okay, I can sort of see those. What else do we want to see? Yeah, I feel like some of these just kind of disappeared. We want to see... We want to see icon point. Okay, yeah, that one's just not drawing its other side. This is, okay, you can kind of see two things. I guess it's not always easy to tell. We can kind of assume that this is the point for those and this is the point for those, but like what the heck happened? If that's the center and that's... Well, okay, so this is just way too far out. So even our icon point is just wrong. Springs. Yeah, oh man. I don't even remember springs as a calc concept. Oh, unless that's just differential equations are used for calculating spring stuff. It's not some abstract concept. Yeah, so those are way out, which is probably throwing things out a bit. Which is probably making my degrees too big, which might be part of it. Doesn't explain why some of them are more reasonable. Spring mass, okay. Oh, that's... My normalize is apparently wrong. Oh, I wonder if I'm getting some zero issues. I require length to be 0, though. Those lengths are different. Oh, okay, yes. Were you no. No, some of this code is we're not normalizing in the other set of equations. I don't... Oh, maybe I am still doing some of that? No, I'm only doing it in the new stuff. Simple harmonics. What the heck? So this is... All right, so where's your midpoint? Okay, you're there. That's reasonable. Where the heck is this? Or maybe it's overlapped one of the other points. I guess that's possible. Yeah, because these got thrown out, and that point is just below the green. Okay, so that's just... because they're not overlapping here. So that seems reasonable. We've got icon point. We've got center. We've got mid A as the in between for one of these. Okay, so mid A is 1 point, one side, and icon point. Icon point is my green. Okay. Not really sure which each is associated with, but given, let's see, do we, icon point had been scaled. Can I put this back where it's supposed to be? Okay, so that's too far. Which makes me doubt this is scaling right at all. Well, what if we... so that's supposed to be normalized. If that's not on the unit circle, something is wrong. Yeah, 7, 7, that might be right. 0, 1, that seems right. Maybe, am I in a scaled... system and I'm thinking about how these are being positioned wrong? Only the final size. Icon point is the green, which is way the heck out there for some of those. So maybe my scale operation is wrong, of all things. I probably don't need the length anymore. Set in geometry. Right, I was looking for zeros. Okay, at the one point I wasn't doing anything to it. Okay, so maybe it might be twice as big because it's a unit across, not unit in radius. So if I want it to be right on the ring, it would actually be 0.5. Okay, so yes, this was slightly scaled down. Okay, so that makes that make a little bit more sense. Where'd the greens go? That's right on there. What's halfway? Halfway is awkward. It would be like 3.7 or something. Maybe we want to make that like 0.4. And that's very awkward for our current code. Oh, actually, yeah, these are working out there. I've just got something funky with the where there's a 0 dimension. Maybe that's something in the line intersection is getting a 0 somewhere. But this is actually looking not too bad. Maybe that's 4. Maybe we have to tweak it a little bit more. Let's figure out where our math went wrong here. I can see. Well, maybe my center calculation's running up a little bit wrong because I can definitely see some problems with this. Okay. So the white is the problem here. What are you? You're blue. Which is overlapped with this, so that might be throwing that off a little bit. Do any of these... -1, 0. These don't seem drastically wrong right now. But it's kind of hard to tell which of those is associated with the problem cases. Maybe we can find a way to filter down the list to just one entry that's the problem case. So our white point is ending up in what we think. Yeah, this actually doesn't seem like a bad center here. But maybe it's getting beyond 90 degrees. Oh, you know what? This would be slightly beyond 90 degrees. Which means I would have to split it more times. Oh, that interesting. Yeah, so that leaves these looking fine, and these are just even more wrong. Okay, so we were good up to... We've got those in about what place we want them. Mid A is the yellow points, which are supposed to be between that point and one of our two endpoints. So that could be these guys, these guys, these guys. Unfortunately, it's kind of hard to tell which is which. What would it take to filter this down? So we've got a list.map. Okay. If I combine take and drop. Okay, that's a cross. It's another one of those. Okay, there's one of those. Which is a working one. Another working one. Obviously the Aphrodite stuff right now. I think we're kind of getting a heart here. Okay, there's a wonk. Is that going to be drop 9, take 1? We don't have some of the other lines as convenient guidelines. Okay. So why the calculated center of our circle, which is whacked. Maybe I can sort of reorder these to be progression of the formula. So we go icon. So we go mid blue, which is between the two sides. That's believable. To the icon point. We take this, we normalize its vector, and that seems like about where we want to place that. We take between one of the other of these. So we take this one between here and here. Now, if that's between there and green, it almost feels a little bit off, but it's pretty much right. And our perp ends up being a vector, and then A2 is a point off of that. Oh, we don't have a cyan. Oh, yeah, that's a problem. Oh, normalize this to 1. Okay, so 2 things. One is that's way the heck over there, but I guess if all we care about is direction, that shouldn't matter. But that is in the direction of the line, not the perpendicular to the line. So I guess my y, oh, maybe I've got this wrong. Maybe, what about, well, now you see, I can do that. But what if y is 0? Is there a separate formula for perpendicular vector? Oh, here's the dot product. The dot product in a given vector. X times blah plus times blah. Let equal 1. This means we have to do the dot product, which is one of those things in that library passed up. Tried to do a quick and dirty cheap way. Actually, wasn't that formula for doing it basically, oh, we looked at this and it's like, oh my gosh. Wasn't it just like the, well, was it xy or yx or xx? Yeah, see, this is so general, it's hard to figure out what it would be for a v2. You see, there's no link for this. Well, a1, b1, a2, b2. So that is x by x plus y times y. Although, I don't actually need the dot. I need the formula for the dot, don't I? Perpendicular? Perpendicular? I guess if That's treating it as a vector, not a point. Pick any value for v1. So this is, wait a minute. That's changing sign of x. And not of y. Now v2 is y. Let equal 1. 0.3, because 3 divided by 10. I don't even need an intermediate for that. So that is, you said let x equal 1. V divided by magnitude. Point 3. Being a unit vector of magnitude 1. Where are we getting square root 10 from? Now 10 is one of the components. All right, so then we actually want to make this perpendicular of the a vector, and we don't particularly care what direction that's in. It's curious, I guess, just because it was a 0 in the right place, that it worked for the others. Hey, and suddenly it's fine. Now, we might still have our skewing problem if our angles are too big. Well, hey, okay so far. Not okay so far. Very, very not okay so far. I wonder, can we maybe get some division by zeros in there? Okay, so that's not one of those. Actually, could I could create a filter function for that. Oh, yeah. So these are... It's got a little helper function. We need... What are you? You don't need the centers. Okay, that's what display is single. So this just would really be trait.boon type. Oh, I need to figure out the adjacency. I need the length. Might be something I need to revisit. Did I end up using that? I didn't. I thought I would be doing some fancy math, and I ended up, well, do I need to leave that there just in case, though? Okay, so that one's fine. Okay. Our reference points are a little bit scary, and I'm not drawing a background there. Maybe I need to normalize that. At least for display. What were you? We did... Well, I guess it's really the vector we need to worry about. Okay. Okay, a unit vector could still... could still be kind of far out there. Boop. Okay. And maybe that normalization actually just helped. Oop. Doop, doop. Yeah, okay. Maybe I should do a little helper function to draw a vector. Or a little line segment. Wait, didn't we draw this already? I thought they weren't duplicated, but maybe they are. And this might end up being empty. We're not gonna go, oh, got all the combos. Are they duplicated? Actually, I might be able to read something out of that. Do a boon Aphrodite Demeter. I guess really what I need to like kind of filter out boon type. Nice. Cold. Why is it saying hidden? That's saying 2. Maybe they did duplicate them for each god. I thought I checked that. Oh, I did have some stuff that was removing duplicates when I was drawing the chart. Well, in that case, we would the ones that seem to be duplicated would have their A and their B reversed, right? So that's on the Aphrodite side. Their Aphrodite. Actually, Aphrodite should only have 2 of these ever. Then it goes to Aries. And we do 2 Aries. Oh, maybe every god has... And then Demeter. And then, yeah. Although it's still picking Aphrodite. Maybe that's they're still listed the racks. But they did duplicate them. Wonderful. So for calculating routing, that's not entirely useless. But I think I only want to draw them once. I guess this would kind of put the onus on their data definition to not have the same requirements for both instances. Now, arguably, that could probably even be removed at the data level because there's going to be more data. I had like, for the chart, we had like printed. We were looking at both lines and the duos themselves. We kind of had that, we stopped using it. Okay, those are the basics. So really only the linked is where that's going to be an issue. And we were doing, if not printed, then add to printed. We shouldn't have that problem with the other stuff. All right, and what was I doing to... was it bin dump? And then I actually had to copy that. $39 kilobytes. Where's the 49? So it wasn't that big a difference. Boon chart. I wish it wasn't hidden. Well, we can check this in the actual... I wish I knew what the hidden was about. Oh, you know what? That's saying 2 hidden. But it definitely shrunk the file, though. Okay, so Aphrodite. Aphrodite. Oh, we're still printing this. Aries. We've already done Aphrodite Aries. Or, no, you wouldn't do that. Aphrodite Aries Zeus. Hello. I am trying to make a nice chart of the boons in a game called Hades in order to better understand how choices I make might impact future choices I could make. All right, so we've done all of Aries. We went to Demeter. And I'm kind of bouncing between figuring out some geometry stuff and data quality issues. Because I extracted a bunch of data from the game itself. All right, so Demeter, we already did Demeter Aphrodite, so now we go to Dionysus, which I already done to Dionysus Aries. We do Dionysus Artemis. And then it's going to kind of go around. Or at this point it ought to. So actually all of the linkages for the duos was encoded twice, which was interesting. And then actually Aphrodite had already been done, so this might be, yep, okay. Okay, so there's that with all of its crazy points. Now, that... maybe I need to make this a parameterized function. Because this got a little bit crazier to draw this thing. It wasn't too bad to... Well, I've also got my debugging stuff in here. This wasn't too bad, and we just kind of changed the parameter here and there. And then we changed our draw color. Which, I don't know if we'll end up doing... Well, those might end up very similar. So we would change the draw color. We would change... where we place that. And actually, looking at it, I might need to bring that down a little bit. We're doing that before. Might be too much, we'll see. That's the center's AB. This would be a version of that that could specialize based on color and icon point radius. I mean, I guess I could actually set this up to pass like the tracing function. That could be a more annoying signature though. And I guess the draw method's gonna be pretty similar between the two of these. So and you are going to be additionally specialized by, it's going to be a color. Display arc produces blah, 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 blah. Display skip 1, so it produces a collage. Oh, and so actually we would do basically that. It's basically occurring. All right, and then this, actually really all this becomes is start with there. Don't dump this just yet. Yeah, I don't like those crossing right on top of where the other icon's going to be. But it's starting to look good. I guess it's this other debugging stuff would be pretty easy to put back. Green ends up being our icon point, which is pretty major. I don't necessarily know if I want it to be green, but... And maybe I actually don't want to be aiming these at the centers. Because that would kind of give us different paths here. So one way to do this is we just kind of keep on going up. We could also go down a little bit. So we take that way out there. That does indeed get it off of intersections, and we don't even need to go do that much. We could bring this down a little bit. It's kind of starting to touch the thing it's actually not actually associated with. Alternately, that does indeed put a bunch of duos right along the same ring. The crossings might get a little hard to follow, though. These won't eventually be color-coded in that way either. Yeah, I think having slightly different distances is going to be better for being able to kind of follow the slope of a particular line. But well, I guess these converge. So that's not entirely bad, because it's going to the same point. Oh, but that will be bad when I'm trying to draw lines from inside these things to its exit point. So doing it like that gives me more distinct exit points. Okay, so part of the reason that this looks cleaner is that the lines are overlapping and you end up with less lines. So if we wanted to separate these more, you'd actually want to like bring the target point for those down. So that this started to intersect lower and lower and lower, and sort of start to hug this maybe a little bit. And you want to bring maybe that point up. So you'd start to get a more distinct exit point up there. So that would have to be another parameter. We have to take the center, which would be essentially a vector. Wouldn't necessarily be a unit vector, but you can move it in or out by some amount. So that's that's not going to be scaled, is it? Well, if I normalized it and then said at this distance, but it's technically a tweak from the center, not a absolute amount. So if we want to say we want to bring you down, that's probably gonna be too much. Okay, all the signatures right? Think so. So end A and end B are those. Oh, we're not actually using. No, yeah, that's the target point. So what am I doing with you? I think I was using an interpolate to do this kind of thing before. It's interpolating from there to 0. I've got my argument order on this. A factor of point A to point B. So if we go from... Sadly, the argument order is inconvenient here. Interpolate. Okay. We were thinking that is in and out. It's not quite how it worked out. Okay, so our down could potentially be more. Well, I think I may actually eventually want to calculate these intersection points. Then I could just draw the arc between those, because I'm going to need to know these anyway to draw from the inside. No, I still have to calculate this center to get the... because that's how our arc works. I was thinking like, you could technically calculate this as like from here to here at some angle. Say that's where I want to intersect. Everything else might even work. I guess let's be cognizant of which direction I was going in here. Right now, we're not really cognizant of which direction that is. And surely there's some way to calculate it. I'm not sure I like this thing where this is like fully arched. I guess that does kind of make them sort of like, it's clearly like the outside system. Where's the sketch? Oh, yeah, we got the same effect there. It was just kind of sloppy, so it wasn't quite as obvious. And it had thinner lines. So I need to figure out those intersections. I guess that's technically an intersection of two circles. We'll have to be able to figure out which of the two intersection points we want. We do not have a source control yet. So dump, new traits, new source file. Git. Oh, so I still have to, I probably do need to separate these for layering purposes. I guess that is blah, 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 blah. Test will work out then. How do we back that off? So we have end A and end B. We're only drawing one of these arcs at a time. So we kind of think of these two things as coming together. We're only drawing one side at a time. So earlier we're doing a blah, and we've got bloop and bloop. So actually we're gonna kind of need these as intermediates. Huh? Did I lose a parameter somewhere? Oh, because you had the 0, 0. Actually, if we assume a constant radius, I might be able to do this as a kind of scale operation. It would change the numbers in the parameter. I should probably close some of this stuff down. Circle, circle, intersect. Oh, well, we happen to know we have this case. R and R centered at 0, 0, and 0. D. These are degenerate cases because it's on 0. This is involved. Well, this is getting into some other stuff here. The chord connecting. Okay, so solving for x results in... I guess this is the x. Oh, this is x, which is the place that intersects. Oh, does that give me what I want? I technically need the... Well, given that you can figure out the points. The chord connecting A equals, which you could use to get the points, finds the area. That's all true, but it's not... Circles by their equations. So I'm guessing this is like x, y, and radius. Or is that squared, meaning it's actually 3 and 4? Might be radius 4? Yeah, lots of squared. Okay, but those fall out. Gabriel's horn. Not a reference I know. Okay, so we have two forms and we use one in the other? Right, quadratic equations, let's have two solutions. Geometric figure, infinite surface area but infinite volume. Ah, one of those kinds of things. How would I... then determine which of those I wanted? They intersect if... Well, that's XYR format. Yeah, that intersection points. A bit more tricky. This is similar to the other form. And there's A. That gets D. Completely too far apart from the inside. Unit vector. The line of intersection crosses the line from one circle to the other. Or where? The height of the intersection line, intersection points. We might be able to know something about how these intersect. We know it's going to be like this circle and wherever the center of this thing is. So it's going to have the line between them, and then the intersection point, wherever these end up crossing. If we could calculate some sort of direction relative to the center, we could say which of those is out. Actually, they're 2 points. They're going to be, since we're centered, yeah, one of them just going to have a longer length. Hmm. Yeah, I can't really do anything with the intersection between this and that because I don't really. Yeah, because I don't know. I'm trying to find out where that point, where that circle intersects the other circle. I'm not sure if this should be a geometry function or not. This is already pretty crazy, but it's at least somewhat related to the problem at hand. I guess picking which point is related to the problem at hand. I just have to return both points. And I see this is line intersection, this is circle intersection. Now you see, this is because I can assume they're overlapping. I don't necessarily need the full version of this. Maybe it's still geometry for this application. And then what's a circle? Okay, so we're assuming a structure of xy radius. Do I know the radius of this circle? Once I have the center, I can get it. All right, so we had circle 1, circle 2, dot blah, 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 blah. Oop. No, why 1? Did I ever search? I didn't search geometry before. As SVG. Maybe I never found this one before. Oh yeah, this is all kinds of crazy stuff. There's an arc. Of course, there's not necessarily a way to... I'd have to like pull stuff out and implement it myself for the rendering side. There's a thing to render this, but... At point with radius, through points. swept around. Inner area circumference bounding box. To arc. Does not have circle intersection, unless it's like a separate module. Intersection with sphere. Bounding box 2D, bounding box 3D. Intersects bounding box. Intersects with a plane. This might be the right level for some of the stuff I'm doing, but it's not going to help me here. X2 minus X1. The distance, I think we might need the distance elsewhere. We technically have a length function for this. We just have to construct the xdy. So this considers these cases. We have to do like a maybe to actually handle this. And then stateful modification. Wait, is dxdy the normal vector? Well, we need the length of the original vector. Which this is vector sub, right? dxdy, I don't really use d anywhere else, so... Oh, no, you do use the length. Well, normalized x, I guess. All right, so circle 1 dot radius. Okay. You're squared. or squared. And then all of this is a term, counting on some operator precedence. That your normal x see, yeah, that's not a length that I can see. And there are some final calculations here. Minus h times nx. Oh, I guess maybe it's a, This is the thing where I was trying to like flip them for perpendicular before and it didn't work. And then u plus. Boon chart. So we need to have gotten our center there. We need to do that for each of these. I guess you could maybe have a helper that's like farther point. Oops. I kept this around. So you are going to have essentially two circles. And I'd keep wondering if I should define actual types for these. Which wouldn't they make be easier? Because that's just going to pass through. Circle intersection. And we say geometry dot length P1 is greater than geometry.length P2. And we return P1, else return P2. Now these should technically be mirrored around the intersecting axis, but that would technically be different math. I don't have a mirror around axis function lying around. All right, terminal point A is the farther point in a circle around end A with radius and a circle around center. No. A circle around center with radius and a circle around end A what did I scale those things to? Display God. Oh, it's a calculated value. I have to make a function for that. Well, it depends on my count. I wonder if I have to pass that all the way down. I already have, okay. So you technically are going to define the radius. We're going to use this in a loop, so we might actually want to capture it there. Do I need you? I do. I do need you. So that's the rotation factor. So that's in terms of the radius and how far we've rotated. Is this the right function? We have to calculate all of this stuff outside and then pass it down to you. Oh, I actually have to call you to get centers too. So maybe this actually there's a place for a like a layout function that does all this stuff. And then where I've been passing around centers, we have like an information struct. So we do need the centers, which is an array. An array of point. And we want the, I guess, the rotation angle by just factor. And it's both the is the diameter or the radius? Well, it's a unit circle, so you scale it to that. That's the diameter, I guess. All right, so we never finished the this. Okay, so we were counting on display God. Oh, no, I got a bunch of collages and then I got the centers from there. Where did I get display gods gave me a bunch of collages. So we return a bunch of collages, not a bunch of centers. I could... Well, I could do the calculations myself. I've been duplicating some stuff. That's just a vector. Well, we have to do vector rotation. We haven't done that yet. Oh. Are you probably the GPU? Well, of course, just touching something else will shut it off right now. I wonder if that is the display driver update, or if Boink's just putting in extra stuff. Unfortunately, there's not like a percent of GPU or anything that really seems to be a good setting for that. So I need like the placement metrics, and then I can get the centers, and then other things are going to need the centers to work, but they also... The adjacent distance is going to be the diameter, which is what we need to get the radius, to know how big those things are, to know where the intersection point is. So there's these metrics that, well, distance, that's the radius out that those are placed. For some reason I thought it was farther than 2.25. We could just have an incomplete structure that we kind of modify and pass on. Or we could just hard code the 8. We sort of have that implied from order and a few other things. Then those all become constants. Oh no, I did the ordering of that document. Well, some of the adjacency stuff ended up assuming it. I might end up wanting to record these points later for drawing the connection points to the inner graph. And here's the paradox. We're going to draw the individual gods. To get their center points. Use the intersections of the lines to determine the intersection points. We need to then use that to connect the inner graph to the outer graph. Maybe I have to pre-calculate centers. So this definitely depends on count, but the centers are going to end up depending on other stuff. So we're going to have like initial metrics, and then we're going to have to update it with centers. Because you're going to be reusing that stuff. We do reuse that. And we're making some assumptions about Hermes and where he is in the list. What am I using flip for? Oh, for coordinate systems, I guess. Which we can just use that here. Did I call it adjacent distance again? Yeah. I guess it's the same. No, this is the adjacent. Oh, this is adjacent distance. This is a little bit. Is this? That's what we scale it to. So that's the radius. We had to calculate that such that the touching point's not the distance between 2 points. So you're using the traits to draw stuff. So you still need the full thing. You still need main. You could get this and this. At which point this just becomes list.drop1. And then we have metrics 2. And that was... All right, so just to get the rest of this stuff hooked up. Metics. All right, we renamed that. Oh, did I? I did use that radius. Now that is more of a straight up constant. It's not really calculated from anything. Okay, so centers ends up being a list. Right, oh, yep. Maybe there's an array.empty. Yep. Okay. No change. So now we have and you're just passing on down. And you're just passing on down. Oh, does dot adjacency take a metrics now? Yeah, technically it's just a count. I guess technically you only need to count two. And well, you implicitly passed that through to here. Metrics. And maybe God Center really would just take a... It's going to be easier on everything else, I guess. Oh, right, this is our intermediate thing. Oop. All right, so now we have adjacent distance is what we scaled that to. So the radius is really going to be that divided by 2. Does that look at all reasonable? Oh, it throws it away because we never use it. And then we want to use that as our terminal points. Okay. Pardon? Are we stuck in an infinite loop? Well, this is still updating. Oh, nope, that's 0. So all our arcs are down at 0, 0. Now, why we're not debug logging is what I don't know. That is supposed to have value. Okay, now I'm really confused. It's like we're drawing this. The types all check out. That restricts you to lines that only include that. And we do in fact have some nans. We have a lot of nans. Okay, so that was the last thing we compiled, had at least the prints in it. So our circle intersection seems to be doing not so great. Those all seem to be valid values. dx, dy, d all seems reasonable. I don't see why this would be a problem. A is a real thing. Is it this? H is indeed nan. And that is just R1 and A. A used R1, so there's nothing bad there. Is that possibly resulting to 0? So we have A. Wait, H is first? Is that just how it compiles? 0.42 and 0.41, well, those are close. I'll give you that, but it's not... Did I maybe misinterpret? That exponentiation operator? Yeah, I guess this is a string. We can actually tape this out. Okay, A2 squared, R1 squared. So we don't do square roots of negatives, is that what you're telling me? Well, I guess that's technically imaginary, right? Whatever library the other person was using just took care of it, I guess. Did I overextend something here? Well, my circle intersections might be completely off. So if we're 0.25, well, guess that could be 0.3 something. I didn't really look too close at the input values. 0.26, 0.08. Well, that's the delta, it's not the center points. So some of those are really far out. 0.48. Those are not on this circle. I kind of want to look at both points now. Nothing we need to do. I keep. That's not the new version. Nope. Okay, so what does... Oh, name changed. All right, only drawing one of the points. You can kind of tell from the endpoint where it is. What the heck? Maybe the size factor wasn't what I thought it was? All right, so too far. And completely inside another. No, here are some abs. So those metrics would be... We've got D. We can kind of abs that out ourselves. Okay, 0.45 R plus R. 0.26. So there's definitely a difference there. D was 1.5. So that does say it's fully enclosed, which means something is wrong. This is just a straight up, what the heck is going on? You know what, on the other side, we've actually got these as, no, there's C1, C2. Somewhere. I guess it's doing it, it ends up doing it first, and then it gets to this, because they're just throwaway values. 0.36 and 0.095. I mean, I can that does seem like an awfully big circle. I guess these are awfully big circles. If it was this one, sure. But the center of this circle is like the end point. It has to be crossing. Could I find... Well, I mean, it is an Aphrodite Zeus. We actually have to find Aries Zeus to get a nicer numbers, maybe. Maybe. It's an Aries Zeus. No, that's placing that there. So that's actually, no, that's Aphrodite meter. Is that all the way around? Psst. What the heck? Now, and then we're scrolling things. No, 0.3, 0.2. No, circle 1, 0, 0.2, 0.36, 1414, 0.96. Oh, right, because the individual things we're doing are here and here. Not actually, they're not actually doing, there's not actually going to be a 1, 0 something. Actually, the circle cutting from here should have a near 0 coordinate, though. Okay, 0. Yes, 0x. That's the larger one. It's large, but it shouldn't... That feels too big. So I think maybe our radius is wrong. Is that C2? No, that's C1. Our radius is the past value. Okay, yeah, 0.36, 0.41. Maybe that wasn't what I thought it was? Because if this is 0.25 for this entire ring, I wouldn't think those would be larger. What else are we doing with that? Oh, we're putting the point out. Okay, so that is the, oh, so that's not radius. That's where the radius where the point is at. The radius of that circle is, do we even have that? I might have to do a difference in length. Well, yeah, we're trying to find the center of it. Yeah, so I don't like radius here anymore. All right, so we have icon point is certainly one of the points that's on there. Geometry dot length. Hey, we have lines. They do indeed appear somewhat truncated, but not properly truncated. Is this the right term? No, that's was I possibly drawing the ring? No, that would put the right would leave the ring outside the scale area. Right, I need the original center, not the end point. There we go. Oh, and boon chart. I might need those later, but right now it's not super helpful. Oh, I'm eventually going to have to calculate these points too. But that's just like midpoint between the centers, so that's kind of fine. This might end up being the kind of thing we have to metrics later in order to have those points. And we'll have to keep around any values needed to draw the arcs. The entire thing can probably be a little bit bigger. Now we can kind of see where those are going to end up. And this might run into some other fudge values. Yeah, looks like my points are absolute. So 2-5. Oh, that actually ends up making the gods effectively bigger because they have more space. So that's not quite the right way to do that then. That actually is kind of pushing the edge a little bit. Will that be a percentage then? I don't think these are the right numbers, but it's a starting point. That's about where we were before. That's a little bit, actually those are a little bit farther. I could probably even work out the ratios. I mean, maybe we want a little bit more space. And then we've got that big outer ring. It was kind of just for sizing purposes. All right, there's still some layering issues. That might be interesting to start looking at placing some duo stuff there. It kind of puts us back to we want to put something there. We've got line layering, line formatting. Gotta figure out actual colors and things. We've got adjacent boon formatting. Haven't done anything with that. We've got cross boon formatting. Haven't really done anything with that. And I might want to do is like dotted lines in the two colors. Oh, we've got to fix colors. Probably gonna be manual because like I know Athena is just the wrong color. Oh, and I ended up doing this straight up. To get a more pleasing arrangement of this stuff, we actually want to rotate this slightly. Which is actually going to be relatively simple. Shift, scale, zoom. Except I need my metrics factor. Okay, that is... There's gods and duos, so we this actually makes this a little bit hairier. Because we've got gods and duos, and that thing needs to get stacked and rotated. And that's kind of like actually the main graph. Which needs gods, metrics, which is part of metrics. It's using the rectangular frame. Now, did I have to do something like, nope, it's still using the rectangular frame. Maybe because it's a stack, it doesn't really know how else to do it. Okay, so that's not trivial. All right, what are... Okay. Maybe what I need to do is well... Yeah, if we rotate these, then that moves all our centers. No, that's the index. Here we go. Now, I don't know if I necessarily have a opinion on which way that rotates. I'll kind of put Zeus back towards the top. And I might actually need to space this out more. And I suppose you have to figure out how to display Hermes, which might actually mean I might actually want to cut out these lines in the middle if Hermes ends up there. All right, we kind of want to do something with this, which is going to be like a whole another animal, but getting something displaying on there would be nice. We have... We need to figure out roughly where Hermes goes first. And we have the individual god layouts. Oh yeah, these things need to get truncated too. Oh, you know, I could have done all that. Well, no, I still need to know where these intersections are, which means I actually have to save that somewhere. Like I could have just given this a solid background and drawn over. Okay, this intersection, that intersection, that intersection would be pretty easy to calculate. These are the ones that we're going to have to save somewhere. All right, we... I think that's pretty much what we did. Although, yeah, we're going to have to come back and figure those out at some time. Thanks for support from subscribers. Is that being fed by the GPU too? Just in the preview, it seems kind of jerky. And that's when I'm usually on. This is well, programming night has been kind of unusual. I want to get more stuff done. And these days are always a little bit unusual. Anyway, good night.